Hi everyone, welcome to Maddie's Hub. This is going to be my first ever Unreal tutorial. Few days back, I uploaded a short clip of PCG, Procedural Content Generation graph that generates a whole suburban city within a few clicks. So this video is going to be about how I created that. Please let me know down in the comments any suggestions you may have for me at the end of the video. I will not be going through the basics of PCG because there are several good tutorials on YouTube that cover PCG extensively. I would personally suggest tutorials by Freetime Coder and Adrian Logut as they explain everything step by step and in a very well structured way. I will put the links down in the description. Now, what I understand about PCG is that there are multiple ways of achieving the same thing. Now, even though I will be showing you one of many ways, you can always explore a different way to do it. And that is the most fun part of using PCGs. So let's get started. Firstly, we'll turn the PCG plugin on. Let's go to Edit Plugins, search for Procedural Content Generation Framework. Let's click on it and restart the editor. I have already done that. So let's create a new level. I'll delete the floor and use the landscape instead. So let's create a landscape. 63 by 63 is good enough. So this is the landscape on which we'll be creating our suburban city. Let's bring it down to 0 in Z. Let's give it some material. I have a few good materials from Megascans here. This mossy forest floor is good. So let's assign it, and we will not be creating just a single PCG graph. Instead, we will make one main PCG graph and a few subgraphs for the separate elements like trees and roads. Now, why we are creating these separately? It's because it makes our main graph much more cleaner, easier to read. I'll create two folders, one for blueprints and one for PCG graphs. Let's save this level. Let's call it map underscore tutorial. I'll create my first PCG graph as the main one. So PCG underscore main. Let's create another one. PCG underscore trees. We'll drop this main graph into the level and bring it to the origin. And let's scale it up around to the size of the landscape. So let's scale it up to 250. And that completely covers our landscape. This yellow box that you see is actually the volume within which the PCG will work. Let's open up this PCG trees. Now you can see it requires an input and an output. So we know that the input is going to be a landscape. So we'll use a surface sampler node. Now what this node does is it will take the landscape input and it will create some random points all around this landscape. Let's grab the output of this node into our main one. So just drag and drop this subgraph. Let's get rid of this output for now. Now in this PCG main, we know that this main graph is in the level. So if we give it this landscape height input, that landscape is going to be this one, which is in the scene. If I go back to my PCG trees and press D on the surface sampler node, you can see these are the points that have been created. They are all of different colors because there is an attribute called density, which is automatically attached to all the points, and its value ranges between 0 to 1, and we are visualizing that in the form of color between black and white. Now right now the points are too many, so let's decrease their number using points per square meter parameter. We'll put a value of 0.005, and let's keep the looseness 0.5 so that they are more evenly scattered. Now let's spawn some trees on these points. So we'll go into the main graph and use a node called static mesh spawner. We can use multiple trees, but for now we'll just add one tree. This tree is from the modular neighborhood pack. This oak one. Yeah. So now our trees are spawned on all the points, and you can see that they are all exactly the same. There is no randomization, and to create that natural randomization, we'll use a node called transform points. Let's visualize it using debugger, and we'll give all these trees a random rotation between 0 and 360 on the z-axis. And as you can see, all the trees are rotated randomly, and we can also give it a scale, minimum and maximum. Let's keep it 1 to 2. And now we have a much more natural looking environment. Let's hide the trees for a second using E, which will disable the trees, and you can see all the rotations and scales. You can see that many trees are actually overlapping, and that wouldn't happen in real world. So we need to remove these overlaps, and there is a node called self pruning, and this node should get the job done. But you'll see that nothing really happens, and the reason is it works according to the bounds of the points and not the meshes that have been spawned on them. So if you can see that the bounds of these points, which we can actually visualize right here, they're not really overlapping. And it's because the bounds are not really the size of the trees themselves. So we need to increase the bounds to this approximately to the size of the trees. For that, we can use a node called bounds modifier. Let's attach it before self pruning. Let's visualize it. For now, I'll turn the trees off. We'll scale it in X in around as to about 4, and Y also to about 4, and in positive Z around 10. So this is almost the size of the trees. So let's see. Now you can see that the overlaps are gone. This is before, and this is after. Let's get our trees back. And this looks much better. Now that we are done with our trees, let's create our blueprint for the road. So let's go into the blueprints folder. We'll create blueprint class of actor. Let's call it BP underscore road. Let's open this up and we'll attach a spline component. I'll make the spline a little bit larger so that when I drop it into the level, it is visible. Let's select this BP underscore road and search for tags, and we'll add a tag called road. Now, why we are adding this tag, you'll see in a few minutes. Let's go into the construction script to create our road along the spline. I have created a road section already in Blender and have imported into Unreal, and we'll be using that one. So let's use a for loop node to go through all the points of the spline. We'll get the spline and get its number of points. Get number of spline points. Now we know that the index starts from 0 and spline points start from 1. So we need to subtract 1. Subtract it, and that becomes our last index. Now, while looping through for each point, we'll add a spline mesh component. And this mesh component will be the road section. This is the road section. Let me show it to you. It's a very simple road. And I have an asphalt material from Megascans. Let's assign that one. For each spline mesh component that we add, we need to set its start and end point. So we need the start position and start tangent. So for the current index, which will also be our current point, let's get location and tangent, its spline point. This becomes our start position and start tangent. Now the end position and end tangent will be the next point. So we'll take index and add 1 to it. And get the similar values of location and tangent. Now the target will be our mesh component itself. So let's attach it, and we need to attach all these components. So we'll use attach component. We'll use the spline mesh component as target and default scene root as parent. Let's compile it. Should work. Let's see. We'll drag and drop this road. Let's create some road. It's like working fine. Our road is looking good, but there's obviously a problem that the trees are getting spawned on this road. So let's fix it. What we'll do is we'll spawn a few points on this spline and use their bounds to remove the points of these trees that are overlapping with the road. So let's create another PCG graph called PCG road. Here we know that the input is going to be a spline. So let's use a spline sampler. And instead of using the subdivision, we'll use distance, which will create points at fixed distance. And the distance increment will set to 5,000. And we'll use the same distance for spawning the houses on both the sides as well. Let's give the output, save it. Let's open the main graph and drag and drop this road PCG subgraph. Now you can see that in input, we don't have access to any spline. So we actually have to use a node called get spline data. And we need to tell this node that which spline do we need. And we will use an all world actor filter and we'll get our spline by tag. And as you can recall, we used a road tag on our blueprint. So that's the one we'll use. And if I press D, I can see the points, but right now I can't see it because the bounds are very small. So in the road subgraph, we'll use bounds modifier. Let's scale it up around 2500, say 1000 in Z. Now this is a good enough bounds to remove our trees and also spawn our houses. Let's go into our main graph and we'll be using a node called difference. We'll be using this node to remove any overlaps between all the tree points and the road points. And you can see that all the trees along the spline are now gone. Now along these same points, we'll be spawning our houses. So let's use transform points and shift these points to one side. Let's say first we'll shift them, say about -2000 in Y. Let's visualize. So these are the houses on the left hand side. We'll again use the same transform points for the houses on the right hand side. So let's make it +2000 and also rotate them 180 degree because the houses are supposed to be looking at each other. And now you can see these are on the opposite side, and we can merge both of these streams of data together. So these are houses, and the bounds are quite large actually. So let's decrease the size. Now I will not be using bounds modifier. Let's use a different modifier, which is called extents modifier. This will do the same thing, but I will show you the difference between bounds and extents. In bounds, we have access to both min and max, say positive and negative side of the dimensions, but here we only have a single value to control both the positive and negative. So let's use it. It We'll use a multiply instead of set, and we'll multiply the bounds by say 0.2 and 0.5. That's uh, much closer to the size of the houses. And let's spawn static mesh. Now, the house that I'm going to use, one of them is from the modular neighborhood pack itself. And the second one is from Sketchfab. This is free model by tech developers, which I'm using. Let's add it. So we now have two houses spawned randomly on both the sides of the road. Now there is one issue that on the sharp corners, we will obviously have a chance of overlaps. We'll use we'll use the bounds to get rid of this. So we'll use self pruning. And now you can see the overlaps are gone. So this is the end of the first part of this tutorial. In the second part, we'll create some details like the fences and bushes and some more trees. If you like this video, please do share, subscribe, and like, and see you in the next video.